nature of the quadratic form. So what's the nature of the quadratic form? That's a very important. So 3 by 3 matrix means 3 eigenvalues is there. Is correct?
Yes, sir.
3 eigenvalues is there.
Yes, sir.
Then what is the first one? All eigenvalues are positive. Then given quadratic form is called a positive determinant. So understood? Suppose lambda 1 value, lambda 2 value, and lambda 3 value. All values may be 3, 5, 7. No
Yes.
negative values involved. And the type of quadratic form is called a positive determinant. Is correct, ma?
Okay, sir.
Next, all eigenvalues are negative. That is called a negative determinant. That means all values are negative means negative determinant. All 3 eigenvalues are. Okay, ma?
Yes, sir.
Next one, sum of the eigenvalues 0, remaining eigenvalues are positive. That meaning eigenvalues lambda 1 equal to 0, lambda 2 equal to 3, and lambda 4 may be 0 or 5. Okay.
Yes,
Sum
sir.
of the eigenvalues 0 and remaining eigenvalues are positive. And that type of quadratic form is called a positive semi-determinant. Positive
Definitely.
semi-determinant. Then what is the previous problem? What is the eigenvalues? Here 0, 3, 15. Then both values are positive and 0 is involving.
Yes,
Therefore,
sir.
this type of quadratic form is called a what? Positive semi-determinant. Okay, positive semi-determinant. So understood?
Definitely. Yes, sir.
Same idea for negative means some eigenvalues of 0 and the remaining eigenvalues of negative, then is called a negative semi-determinant. Okay, negative semi-determinant. Okay, Mama.
Yes, sir.
Suppose the eigenvalues are positive and also negative involving, and that quadratic form is called a indeterminate quadratic form. Indeterminate quadratic form. Okay. Suppose lambda 1 equal to 3, lambda 2 equal to minus 5, lambda 3 equal to 7. Therefore, positive and negative values, eigenvalues are there. Therefore, this type of quadratic form is called a indeterminate quadratic form.
Okay, sir.
Correct? No?
Yes, sir.
These are the basic property. How many properties there? One, two, three, four, five
Five.
properties very important. Remaining are very easy. Remaining three concept. One is called a index. Next one is called a rank. Another one is called a signature. Another one is called a signature. What do you mean by index? What do you mean by index? Okay. Number of positive eigenvalue. Number of positive eigenvalues is called a index. You check that
Okay, sir.
previous problem. How many positive eigenvalues is there? 3, 5 only
Three.
positive eigenvalue. Correct?
Yes, sir.
Therefore, what is the index here?
Two.
2. Okay. The next one is called a rank. Number of non-zero eigenvalues. What is the rank of non-zero eigenvalues?
Two.
2. Therefore, index 2 and rank 2. The next one, signature. The number of positive eigenvalues minus number of negative eigenvalues. Then what is the result? Number of positive eigenvalue 2,
Two.
negative eigenvalue 0. That result is also 2
Two.
only. That's all. This is a two more question, ma'am. Please take that. Maybe given the matrix is given or eigenvalues are given. Find the index, rank, or signature. Okay. Otherwise,
Yes.
semi-determinate or determinate or positive determinate or negative determinate. How many properties or how many rules is nature of quadratic form? 11 rule is there. Okay, 11 rule. Okay, sorry. 1, 2, 3, 4, 5. 5 plus 3 is 8 rule is there. Okay, this is the nature of the quadratic form.
Okay, sir.
This is very important. Two more question. Please note this. Otherwise, I share this notes. Okay.
Okay, sir.
Next one is called properties of eigenvalues and eigenvector. Next one is called properties of eigenvalues and eigenvectors. So first property, it's lambda 1, lambda 2, lambda 3. is the eigenvalue of A. Okay.
Yes, sir.
Then sum of the eigenvalues equal to trace of A. Trace of A. Please check that previous problem. What is the sum of eigenvalue? 0 plus 3 plus 5, 15 equal to
Yes, sir.
18.
Yes, sir.
Then what is the diagonal value of A? What is the diagonal value of A? What is the diagonal value of A? Ma? 18. 8 plus 7 plus 13 is also 18. Is correct?
Yes, sir.
This is a new one. Okay. Sum of the eigenvalues is equal to sum of the eigenvalues is equal to trace of A. This is the first property. Okay, ma.
Okay, sir.
Second property. Product of eigenvalues equal to determinant of A. Product of eigenvalues equal to determinant of A. So already know previous problem determinant equal to 0 already you know.
Yes,
What is
sir.
eigenvalues here? 0 into 3 into 15. Therefore this eigenvalues product of eigenvalues is also 0.
Yes, sir.
Okay, this is another problem. Third property, lambda 1, lambda 2, lambda 3 is eigenvalue of A. Then lambda 1 power n, lambda 2 power n, lambda 3 power n is a eigenvalue of A power n. Is understood? Any difficult? Suppose A squared eigenvalue, eigenvector. Find A squared eigenvector. That meaning lambda 1, lambda 2, lambda 3 are eigenvector meaning you want to square. Suppose lambda 1 value is 2, lambda 3 value is 2 value is 1, lambda 3 value is 3. Then
Yes,
what is
sir.
the eigenvalue of A square? Apply care. What is the eigenvalue of A square?
4,
2 square, 1 square, 3
3
square.
square,
That is called 4, 1,
1,
9.
9.
Okay.
Yes, sir.
Same idea, n equal to minus 1. Then what is result? A inverse. Therefore, A inverse. Then what is the eigenvalues here? 1 by lambda, 1 lambda 1, 1 by lambda 2, 1 by lambda 3. That meaning, fourth property, what is the fourth property? Lambda 1, lambda 2, lambda 3 are eigenvalues of A meaning 1 by lambda 1, 1 by lambda 2, 1 by lambda 3 are eigenvalues of
A inverse.
A inverse. That is a very important property. Okay. The fifth one, suppose matrix, suppose matrix 1, 2, 3, 0, 5, 7, 0, 0, 8. This is called a triangle, maybe upper triangle or lower triangle, any triangle is there. This matrix is called a triangle matrix. Okay.
Okay, sir.
The triangle matrix A, then what is the eigenvalue? Need not find characteristic equation.
1.
Directly you writing the diagonal value. Directly you writing the diagonal value is called the eigenvalue. Okay, lambda equal to 1, lambda 2 equal to 5, lambda 3 equal to 8. This is a shortcut mode.
Yes, sir.
Suppose given the matrix is a triangle, then diagonal values are called a eigenvalue. Okay. Sixth one, maybe diagonal values is there. Maybe diagonal values. 3, 5, 8, here 0, 0, 0, 0, 0, 0. Maybe diagonal matrix is given. Therefore, eigenvalues is also diagonal one. Okay. You know diagonal matrix.
Yes, sir.
Therefore, what is eigenvalues here? 3, 5, 8 only eigenvalues. Not needed characteristic equation you find. These are the eigenvalues. Okay.
Okay, sir.
This is sixth property. Okay, ma.
Yes, sir.
This is a very important properties for the eigenvalues and the eigen. Maybe there are remaining four concepts that for total 10 properties is there, 10 or 12 property. But these are the very, very important properties for the eigenvalues. Please note that. I also am sent this notes also.